Okay, let's take some notes. Yes, quadratic functions x plus c is a form of quadratic functions. We can also show another times quadratic functions. In addition to this, you can also see it in this and quadratic function. Write it rather than 0y. Okay, function. And sometimes you can see it like this. Analyze the general form. Let's analyze the general form. If you want to x variable or variables, I want to give you the formula, roots of that equation. So by using minus b minus plus b square minus 4ac over 2a. Okay. Okay. This is the formula. As in addition to that formula, we can also we call that part as discriminant. If you check, you can find the number what and 0. That time you have to, if the discriminant is just a second time the root. Okay, there is only one root, but if the discriminant is greater than sorry, is less than 0, that time no roots. Okay, in other words, no solution. Okay, in other words, no x variables, equation 0. Okay, making equation 0. In other words. Okay. Yes, let me show you some other details about it. Okay, assume that our equation is okay. Ax squared plus bx plus c is 0. You can also write that equation after simplifications of a's like this. That time x squared plus b over x times c plus c over a. Still, this is the same quadratic functions. No any problem with it. But as you can see, we get rid of the coefficient a from x squared. Okay, left it here. So I want to show you some calculations. For instance, assume we sum the roots, and that time let's look at it. Assume that we sum the roots. Let's look at it. As you can see, after calculation, you see that it equals to minus b minus sorry. In addition to this, root 1 and root 2, the multiplication of root 1 and root 2 is also minus b. Yes, times minus b plus n. Okay. Rather than this equation, rather than this calculation, you can also show it as minus b squared, as you remember, minus, yes, like this. Okay. So after each calculation and separation and simplification, you are going to see that c over a is the solution. You can understand what I did, I think, because right now, rather than that form, as you can easily realize, rather than that form, you can also summarize the equation as right now x squared minus x1 plus x2 in bracket times x plus x1 times x2 is 0. Okay, so to sum up, we can say that rather than coefficients, you can also show the quadratic equation in terms of the roots, as you see in here. Okay, this is the another summarize for that quadratic function. These are important points because during the calculations you may need that details according to questions. Okay. Yes. After some details, let's go on with the graphs of quadratic functions. Okay. It is a little bit harder than linear functions, but if you be careful, if you understand the important details, important clues, you can solve it. You can solve it easily. Okay, you can solve it easily. So let's look at the graph of quadratic functions. Right now, for each type of quadratic functions, you may need different solution types. For instance, let's choose the first type. If you see such a type, it is always same for each functions to show on the xy coordinate plane. Firstly, find the x and y intercepts. Okay. Firstly, find the x and y intercept. That's why x is 0. So a times. Just a second. I better show the function like this. That times, as you can see here, x is 0. So but just a second, I'd better show it with an real example. Assume that our quadratic function is like this. Okay, assume that our quadratic function is like this. So let's start let's start with finding x and y intercept. X is 0, that time 2 times 0 minus 5 times 0 minus 3, and it is y. As you can realize, y-intercept is 30. What about x-intercept? That time y is 0, so 2 times x minus 5, x minus 3 is 0. In other words, x is 5 and x is 3. These are the roots. These are the x-intercepts. Okay, so because it is a quadratic function, it may have, as you see here, it may have two different, we know, roots. So then I'd better show that intercepts firstly on the xy coordinate plane. Yes, this is 3, this is 0.3, and this is 0.5. Okay, this is 0.5, and y-interception is here 30. Okay, as you can hear, actually I can draw, the graph. Right now, it is an parabola. It is the graph of a quadratic function. No problem. But if you want to define properly a quadratic function, you may need also vertex of the quadratic functions. It is very important. Vertex. You may need the vertex. So our second step right now is find the vertex. Actually, vertex is maximum point if the quadratic function shape is concave up. Okay, sorry, just a second, concave down. If the shape of the quadratic function is concave down, we call that shape concave down. Okay, that time vertex is the maximum point. This is vertex. But vertex is minimum point. Okay, if the shape of the parabola is concave up. Okay, if the shape of the parabola is concave up, that time vertex is minimum point. Okay, so when you look at the shape of the graph, you can easily realize that vertex is the minimum point. Okay, so it means that you need to find the vertex. Okay, so Let's try to find the vertex right now. Let me erase this part. Okay. So let's find the vertex. Finding the x-coordinate of vertex. As you see, vertex is a point. So yes, find the x-coordinate, x of vertex. Okay. In other words, x-coordinate of vertex is called axis of symmetry. Okay, symmetry. So all you need for axis of symmetry, x1 plus x2 over 2. Okay. So for that question, it is 3 plus 5 over 2 is 4. This is the point for axis of symmetry. This is the point for right now axis of symmetry. Okay. Let's find the y-coordinate of the vertex at the same time. Right now, all you need is just use that value. So it is, as far as I remember, it was y2 times x minus 5 and x minus 3. And that time it is y equals 2, 4 minus 5 and 4 minus 3. Yes, it is also minus 2. Right now, everything is ready for an x and y intercepts. Your graph is ready. Okay, is there any question? Can everybody understand?
Yes.
Okay, good, really good. So, other forms. Yes, right now minus h in bracket square plus key is y. In that form, I think finding vertex of the vertex, if you see in that form, h and key, okay, at vertex, you can easily find the coordinates of the vertex here. So, yes, 2 times x minus 5 in bracket square plus, if you see such a vertex is minus 1. Then all you need just 2 times 0 minus 5 in bracket square minus 1, 49, okay? And this is y-intercept. X-intercept, that time 2 times minus 1 is 0. Yes, is 1. In other words, x minus 2. Yes, in other words, 5 minus or plus, yes, 1 over 2. Okay, so easily draw the line. Sometimes you don't need, if you x and y-intercept, only maybe y-intercept or vertex is, it may change according to question. So the set is here 49, and x-intercept. We know that this is the axis of symmetry. X is 5. X is 5 at axis of symmetry. Okay, x is 5 at axis of symmetry, and let's draw the function. Okay, let's draw the function. Okay. Yes. Okay, and we know that this is minus 1 and this is 5. Okay. And your vertex is, as you can hear, your vertex is here, the minimum point. Vertex is minimum point for that graph. And yes, as you can see, this is the graph we need. Okay, let's check the other form. Before checking other form, you can also see such kind of questions. Be careful for that question. Assume that right now, this is the quadratic equation once again, and find the same values. Vertex is 5 and 1. Okay. What about x and y intercepts? X is 0, so 2 times 0 minus 5 in bracket plus 1. It is 51. This is y intercept. Okay. What about x intercept? Y is 0, so 2 times x minus 5 in bracket square plus 1 is 0. Be careful for that step. 2 times x minus 5 in bracket square is minus 1. Is it possible? No, it is not possible. That's why we can say that no intersection or no intersection of x-axis. Okay, x-axis. That's why all you need here is just y-intercept and vertex. Okay, by using vertex and y-intercept, you can easily define and display the quadratic function. So no any x-intercept. Let's point them. Okay, y-intercept is 51. Y-intercept is 51, and vertex is 5 and 1. Vertex is 5 and 1. Okay, and this is the vertex. So yes, let's draw the function. This is the function. As you can realize, vertex is 5 and 1, and no x-intercept. No x-intercepts. Okay. Yes. Let's check the another forms. Yes. Our last form is a times x minus h squared is y. You can easily realize that form display the function tangent to x-axis. Okay, if you see such an equation, you can easily realize that it is tangent to x-axis. In other words, there is only one x-intercept. Okay, so let me show you with an example. Again, 2 times x minus 3 in bracket square is y. Okay, let's use the same. Right now, vertex is because there is no because there is only one vertex. Sorry, because there is only one x-intercept and it is vertex. That time your coordinate for the vertex is 3 and 0. Okay, so yes, we know that it is tangent to point 3, and let's find the y-intercept. So x is 0. That time 2 times 0 minus 3 in bracket square. So as you can see, it is 18. This is y-intercept. Okay, by using that, you can easily draw the line because it is tangent to x-axis. So yes, we see that this is 3 and this is 18. This is 18. So yes, this is our parabola. And vertex is on vertex 3 and 0. Vertex is on the x-axis. Okay. Yes. Okay. Maybe we'd better check some questions and then we can analyze better. Let's practice. Okay, let's practice. Yes. Look at the practice module. And yes, quadratic functions. Yes, quadratic functions here. Okay, you can also check other questions. Okay, start. So yes, start with the first one. What is the solution of the equation we are asked to find? In my mind, we are going to use the same method. As you know, the solutions is x1 and x2. So assume that it is in that form: a times x squared plus b times x plus c. So yes, minus b minus plus. Yes. Okay, here b is -1, so -1, minus and plus -1 in bracket square -4 times 1 and 1 -1 over just a second, over 2 times 1. In other words, 1, yes, in my mind it is like this. So yes, yes, I think this is the final. Yes, I think this is the final solution. If you look at the solution, option D seems true. Okay, option D is the one of the solution. Okay, so let's check this question. Equation B, let be the equation of parabola. Okay, if we know that this parabola cross x-axis only at one point, what is the value of c? If you see such an equation and if you are given the information that x-axis is the only point, uh, only one point, that time we can understand that equation has one solution. Okay, equation has one solution. In other word, discriminant is 0. Okay, so let's show the formula of discrimination. As you see, if the equation is like this, that time discriminant is b square minus 4ac. So b is here 4, square minus 4, 1, and c, and we know that it's 0. That time 16 is 4c, so c is 4, that question. That's why option A is true. Okay. Yes. When we look at this question, we know some clues on the graph. So by using that graphs, thanks to that clues, we are asked to find the equation of the graph. Okay. As far as I see, we know the coordinates of the vertex. We know the vertex. So vertex is here. Vertex. Okay. Vertex is -2 and 4. Okay. Okay. Vertex is so x intercepts. Okay. And x intercepts x1 is -4 and x2 is 0. Okay. By using these values, okay, when you look at the options, you are asked to find the equation in that form. Okay, I couldn't remember the name. As far as I remember, it is the vertex form. So you are asked to find the solution in vertex form. That's why assume that your equation is y equals a times x minus h in bracket square plus key. Okay. Yes, right now we know the vertex, so we can emphasize that. Just a second, we can emphasize that h is here -2. Yes, right now by using the vertex, we can say that it is a plus 2 in bracket square plus 4. But big value of a. Okay. So to find the value of a, I think we can use one of the points. For instance, let's find this point. Okay, let's use this point. If you use this point, you know 0. In other words, is -4 plus 2 in bracket times and plus 4. That 4a is -4. In other words, a. So our equation is y equals -x plus 4. As far as I see, option C is true for this question. Can everybody understand? Okay, good. It's really good. I think it is easier because you know the equation, quadratic equation, and you know the points on it. All on the x and fx. So rather than fx, we can. That's why 0 is 25 square is 9 over 25. In other words, option A is true for this question. Okay, for which real values of C does solutions? Okay, there are two options for real solutions. Other than 0, two real solutions. And if the discriminant is 0, that time one real solution. But as you know, all you need all you need to know whether you have a real solution or not. That's why you can also think about these two options. Okay, you can also think about these options. By using this assumption, you can say that discriminant is greater than equals from 0, greater than 0 and equals to 0. Yes, all you need just to find discriminant here. So discriminant is 6 square minus 4 times 1 times c is greater than and equals to 0. So 36 is greater than equals from c. Greater than and equals to c for c. So C is yes. This is the solution for that question. Again, option C is true for this question. Okay, right now, let's check another question. Okay, the graph is shown where the function f is defined by yes. When you look at this question, we couldn't study these three third degree equation. I know, but no matter which equation it is, all you need just understand how many x-intercepts there are on the graph. Because if you see 3 x-intercepts, it means that there are 3 roots or 3 x solutions for this question, for this equation. Okay, and we see that it is an third degree equation, third degree polynomial equation. So and at the same time you see three different x-intercepts, means that you have 3 x values. Okay, so option C is true for this question. Okay.